Hello, this is Mr. McGovern and welcome to the first video in the Level 2 physics series in mechanics. If you are wanting to get onto any of the other series, the electricity one for example, mechanics is a really good one to start with. You build up a lot of the basic knowledge that's used all the way through physics. This video here on constant velocity, the first video on constant velocity and graphs, is a bit of a revision from year 11, level 1 stuff. But regardless, it's still really important to understand all these basics that we end up building from to develop all the ideas right the way through physics. So we're looking at constant velocity as described through graphs. So let's just say we have a car at a start line and over a period of time it moves at a constant velocity and we wanted to graph that. The graph would look something like this. A distance time graph, let's say it goes to 100 meters. It's constant velocity, so the gradient is the same all the time. That red line on the graph is a straight line. It has the same gradient everywhere. Alright, what if we wanted to add a blue car, but the blue car did not start at the start line? It started 20 meters ahead, but it's going the same speed, but it's just always 20 meters ahead of the red car. So the blue line would have an initial position of 20 meters. So you can see that blue line looks like it's been shifted up in the graph and gets to 120 meters. So if we're still calling this a distance time graph and we say how far has the blue car gone, you read off the graph, would you say the blue car's distance is 120 meters? No, that doesn't really make sense because it started at 20 meters. Okay, it still traveled 100 meters, but it started at 20 and got to 120. So the first thing we're going to do in year 12 is we're going to get rid of this idea of labeling a graph with distance. It's better to label it with position. So the blue car started at position 20 and finished at position 120. So we're using position. The symbol for position is X. So you see I've changed that symbol on my graph from D to X. So this is now our XT graph, and the official symbol in physics for position is X. Alright, let's say we had a green car. This green car is going faster, so it gets down the 100 meters a lot quicker. What you'd see is the line on the position time graph is steeper. So there's the green line there. It's steeper than the blue or the red one. And the gradient, which is the steepness of that line, represents its speed. A larger speed is a larger gradient, or a larger speed is a steeper line on the position time graph. Finally, what if we had a yellow car and this yellow car started near the 100 meter mark and headed backwards? So here it would start at a high position, at a large position, and it would move to a position 0 as time went on. And what we see is that yellow line has a negative gradient. Okay, if I was to work out the rise over run, and I end up doing that in one of the next two videos, we see that to represent something going backwards, it has a negative gradient from this position time graph. So the summary, which is probably not new to you, we're using position instead of distance on this graph, and the symbol for position is X. A larger gradient is a larger speed, as shown by the green line, and a negative gradient represents something moving backwards.